Colleagues and students, thanks for coming to our seminar series for today. And today is a great pleasure to welcome our student, Katherine from the Merwe, who is going to talk to us about benchmarking benchmarks. And this is a replication study, which is going to be submitted as a journal of Pacific Basin Finance Journal. And the title of the paper is a paper which is published in the Journal of Financial Economics, which is a A-star journal. And in that journal for Basin Pacific Finance Journal, they have a section whereby all the papers that are published in the A-star journal need to be reproduced or replicated. And then, so in that paper, they focus mainly on the top 5 currency, like US dollar, USD, Europe or Japan and so forth. But Katherine is trying now to replicate the study and add more emerging markets like South Africa, and Katherine is also going to talk to us. So Katherine is my master's student, and really happy for her to accept coming to talk to us and explain to us what are the benchmark rates and benchmarking benchmarks. Over to you, Katherine.
Thank you, yes. Yeah, what a wonderful opportunity to be here. So let's get right to it. So the paper I am trying to replicate is the benchmarking benchmarks paper by Brugler et al. And basically, just a quick overview of what we're trying to achieve is we have these interest benchmark rates that are changing now to these new alternative reference rates in the world. And this is called the interest rate reforms. And during this process, we want to find out, are these previous benchmarks, were they better or were they worse compared to the new benchmarks that we are trying to install into the world? So in doing this, we are looking specifically at the noise in the benchmarks and trying to determine if there's less or more noise in the new benchmarks compared to the previous. So we do this using state space modeling, applying a Kalman filter algorithm, and then comparing some metrics that I'll go through. So first of all, why are we moving from these previous benchmark rates, also known as the London Interbank Offer Rates? So during the 2008, 2009, or between 2008 and 2012, there were these huge manipulation scandals of this interest rate benchmark. And this was mainly due to how this interest rate was constructed. So the LIBOR rate was basically constructed by bank surveys based on subjective forward-looking views on what term rates should be. And due to this sort of led lots of opportunities for manipulation of banks and financial institutions to profit from these rates, as they had complete control over them. Also, during the global financial crisis, we saw a big move from uncollateralized markets to collateralized trades. And this also influenced the liquidity of the LIBOR benchmark, as the subjective estimates were supposed to be based on these uncollateralized trades. Now we are moving into a more collateralized market, which made the market much smaller. So this led to the development of these alternative reference rates by the Financial Service Board. And these are based on real and observed transactions, not subjective estimates. And these are backward-looking, and they are mainly supposed to be using liquid and large markets. So over here in the left, or in the table on your right, the left panel is the old rates, and on the right we have the new rates. For the US market, we have the secured overnight financing rate. In the UK, we have the sterling overnight index average. In Europe, we have the euro short-term rate. Japan, the Tokyo overnight average index. And in Switzerland, we have the Swiss average rate overnight. So these are the main players in the benchmark interest rate world. And this is what, these are the rates that Brugler et al. Are focusing on in his paper, or their paper. So why do we want to why focus on noise? So What is benchmark interest rate noise? It is this random fluctuation or distortion in the rates that do not reflect genuine market conditions. Or in other words, the movements in the rates that are unrelated to the fundamentals. They don't signal real changes in credit risk, monetary policy, or liquidity. And noise in benchmarks can lead to the following issues: inaccurate pricing of financial contracts. So many financial instruments, loans, swaps, derivatives, futures are all tied to these benchmarks. We have unfair wealth transfers. Even a 1% basis point can lead to billions on billions of money being transferred just due to some noise. We have reduced market efficiency, as these noisy benchmarks interfere with the market's ability to allocate capital efficiently. And if prices aren't informative, investment decisions become quite skewed. Naturally, we see an increase in volatility and uncertainty, and perhaps the most important of all, there's this lack of confidence in your benchmark because of this manipulation that can happen. So, based on these problems that could happen due to noise, that raises this question of, are these new benchmarks truly better or not? So how are we going to determine the noise and the true rate of these benchmarks? So we do this using the state space setup, and specifically we are using the framework originally based by Mengfeld et al. And this is due, and he uses a sequential state space model. So in our state equation, we have our hidden or true efficient rate. So that is the prop, or that is got the true and the most amount of signal of what is happening in the market. What we see on our side, we see LIBOR, we see the alternative reference rate, and that is in the observation equation, which consists of the hidden rate plus some noise. So in our setup, because LIBOR, the LIBORs and alternative reference rates, they can be published on the same day. But on the one day, you will have one true effective rate, but noise in LIBOR and noise in your alternative reference rate. That's why we have an observation vector depending on the time of day that the rates are published. So our setup will look something like this. So on day 1 at 11:55, we see LIBOR is posted. From LIBOR, we have a true efficient rate, which is common to the alternative reference rate. But in LIBOR, we have this true noise variation, and we've got noise that is unique to the benchmark itself. Similarly, on the same day at 1 o'clock, we see the US alternative reference rate is posted, having the same efficient rate as LIBOR, but with different noise and different information variation. And we do this for every single day in our data frame or period. So just to make indexing a bit easier, we can just let S equal to T and tau, and then we end up with the following dynamics. So we can actually extend our model to include some time varying controls, as benchmarks are actually influenced by economic factors like policy rates, credit, and liquidity. And we do this by using this bottom observation equation, where we have a constant term mu, which can just be the spread between the LIBOR and AR, xt being the policy rate or credit spread that we try, credit default swaps that we want to include, and then just another coefficient vector that we need to estimate in the process. So how do we extract the true rate from all this noise? This is done using the Kalman filtering algorithm. This is basically the workhorse of the whole paper. So at a high level, this is a filtering algorithm that allows us to estimate the efficient rate at each point in time using our noisy estimations, our noisy observations. And it works in 2 stages. We have a prediction stage and an update stage. So in the first step, we predict the efficient rate based on yesterday's estimate. We carry forward the previous estimate as our forecast today, basically. And in the second stage, we also update our uncertainty of this estimate. For initial values, you can just use the first day's interest rate, and obviously the more confidence you have in your initial estimate, the lower your covariance initial estimate will be. In the update stage, after we've observed today's benchmark, then we can determine what our prediction area is, and we can determine the covariance of our prediction area. We can then also determine the Kalman gain, which tells us how much to trust in our new observation. If the benchmark is more precise, we update it more. If it's noisy, we update it less. As you can see in the next step where we use the Kalman gain, how this influences our estimate. And then we carry on with this iteratively until we are done with our time series period. At the end of this, we should have, at the end of the Kalman filtering process, we should have a time series data set with our efficient rate estimates, our benchmark specific noise levels, and also our information variance. And using these metrics, we are able to calculate our information share, which tells us how much a benchmark is contributing to the true rate. And it's a measure of price discovery. So obviously a higher information share is better. We can also calculate our noise share, which tells us the proportion of the benchmark's total variance and how much of this is just noise. Lower is obviously better. Both the information share and noise share are relative to the benchmarks that we are comparing. Information to noise ratio, this just gives us a summary statistic of the benchmark quality. So onto the replication of the results. I was able to reproduce the results in the paper. So the first results consist of the data set used by Great Britain, so using the sterling pound. And what we really are what's great to see is this reduction in noise share, specifically after the transition period. So the transition period from moving to LIBOR to SONIA, the new alternative reference rate, was the 23rd of April 2018. So in the noise share, we had a reduction from 88.31% to 11.7%, which is quite a massive reduction in noise. But if we look before the transition period, we actually see an increase in noise, which is something to note. And this could have been due to how SONIA was constructed. So before the transition date, the alternative reference rate did not have mean trimming. They just used all of the transactions. After the transition date, they trimmed the top 25 and the bottom 25% of the data used in their calculation out. But we also see after the transition date a reduction in how much information this alternative reference rate produces. I was also able to replicate the results for the European Union or the EU, and they didn't have any data before the 1st of October on their alternative reference rate, so there's no transition period for them. And it's great to see that our model works with negative interest rates as well, because that could have been an issue perhaps. And again, we see a massive reduction in the noise share. And here we see actually an increase in the information share. So I think they're doing something right with their benchmark construction then. Okay. Lastly, I tried to replicate the US market. I had mixed successes with this. I got 3 out of the 6 data results correct. The other 3 with asterisks, I need to go check those again. But the big player, the amount of noise that we see in this new benchmark is astounding. The previous benchmark had 0% noise, but the new benchmark is totally noisy. And the paper by Brugler et al. tries to or suggests that this noise could be due to how the benchmark is formed. So what differentiates the US benchmark from the previous two we saw is that it's based on collateralized US repo, US treasuries, whereas the other two benchmarks were based on uncollateralized transactions. So with the collateralized market, the volatility of the market is determined by the supply and demand of these collateralized transactions, which adds a lot of volatility to this rate, which is, it's quite a massive number to consider. But not much research has been done on this, so there is actually space to determine how much does collateralized benchmarks affect the noise in the rates. So after analyzing these results, we have seen some interesting factors that came across in how these benchmarks are constructed and the markets that they're based on. And Brugler suggested the following hypotheses. So he suggested that ARRs are supposed to be less noisy by design, as they are supposed to be based on deeper and larger underlying markets. So small distortions should be sort of flooded out or averaged out by the rest of the market, whereas a narrow market, a big price distortion could have a big influence on the reference rate. A more homogeneous underlying market would lead to a less noisy benchmark, so trades of similar kinds that have similar effects should also lead to less noisy benchmarks. However, we see there's a trade-off between how deep your market is and how homogeneous your market is. As the larger you make your market, the deeper it becomes, the more different types of trades you include in your market, making it less homogeneous. So there is this trade-off. And as we saw with ZARONIA, the statistical methods and trimming of outliers do make a difference, as we saw pre-transition and post-transition. And a big player, the less manipulative incentives lead to less noise. And a big one way to sort of gauge this is the volume of our derivatives market to the volume of the underlying benchmark. As more trade, if you have higher derivatives to the size of your market, few trades of these derivatives could change this ratio, and this could lead to more manipulation, which could in turn increase the noise of the market. So after all of that, we are now going to look at the South African market, which is the main focus of my study, I think. And all the information on this new interest rate is available on the SARB's website, all the rates, all the data as well. So jumping right into it, we see that ZARONIA, which is the South African Rand overnight index average, was started to be published on the 2nd of November 22, and before that we had ZARONIA proxies, which were just estimates. And ZARONIA is published at 10 o'clock every day, as well as the other benchmark rates. So ZARONIA was made to replace this Johannesburg Interbank average rate, which was sort of similar to how the London Interbank offer rates were calculated based on bank quotes by a panel of the contributing banks, and also was forward-looking. Important to note, JIBAR, which ZARONIA plans to replace, only consists of term rates from 1 month and longer. If we look at ZARONIA, it's based on overnight unsecured repo transactions, but it's an overnight rate. So our tenors don't exactly match for ZARONIA and JIBAR. And also we see that ZARONIA is a trimmed volume weighted mean. So in order to compare an overnight index to an overnight index, we also look at the South African Bank overnight rate, which is the current and legacy overnight benchmark rate of South Africa. And this is, in a similar fashion, a backward-looking rate, but it's based on the largest interbank deposits other than the repo rates. and includes these implied short-term fundings in the foreign exchange swap market, which is currently being quite high and volatile. Going through the same process as to obtain the previous results, we actually have some good results for ZARONIA compared to SABOR. It is important to note ZARONIA is not replacing SABOR, as they are both going to be used in the future, but encouragement is going to be for ZARONIA. And I think this is a good encouragement to see why we should use ZARONIA, as if we just look at the noise share component, we see a massive reduction before and after the transition period of the 2nd of November 22. If we look at post-transaction or the post-transition period, from about 90 to 11%, which is huge. On the other hand, we do see there is less information in ZARONIA. This could be due to very few, it is new, ZARONIA is quite new, very few trades are happening on ZARONIA. And also, because of the trimmed mean of ZARONIA, there's less variance in it. The high and the low trades are removed, as we saw, but in SABOR, we had this extremely volatile foreign exchange swap market that's also playing a factor. So that's something to further investigate. So I think that is why we see all of this information being pushed onto the SABOR market and not onto ZARONIA. But if we just focus on noise, it looks great. So in order to try and compare JIBAR with ZARONIA, as JIBAR only has a 1 month, 3 month, 6 month, etc. tenor, we thought we'd compare the ZARONIA compounded 3-month average, which is the suggested new term rate that the SARB is recommending institutions to use, even though it's not official yet. And this compounded 3-month average is quite a smooth rate, and it's calculated based on the overnight rate. So we use the 3-month rate, as this is the most commonly traded rate in South Africa. And we get it could be good results, but I think some more investigation needs to be done into how the algorithm plays out, because this 100% to 0% in a way could be a bit suspicious. But if this is true, this is actually astounding. So to conclude, what I have done, I've replicated Brugler's paper, and I was able to assess the benchmark performances of the currencies that he used, and I was able to obtain most of his metrics. And I've also applied this to South Africa's benchmarks, JIBAR, SABOR, and ZARONIA. What are the implications of this paper is to realize how these reference rates work, the underlying markets that determine these reference rates, especially in terms of depth, homogeneity, statistical robustness, and manipulation risk, as these all impact our benchmark. Besides that, these methods are great, and they offer a toolkit for evaluating other benchmark reforms in other markets, as we see this massive transition happening in the world in other countries such as Mexico, Brazil, India, etc. So the next steps for my study is to study the impact of wealth transfers due to noise. I want to do some more robustness checks, and I also want to expand this application to these other markets that are going through the interest rate reforms. Thank you.
Any questions to Katherine?
Yes.
Thanks. So I might have misunderstood earlier. Sort of up front, you might have suggested that the sort of the true underlying rates is the same between LIBOR and an alternative.
Yes.
Is that what you're saying?
Yes, because that is an assumption that we are. That is true, because on the same day there's supposed to be one reference rate. So they're supposed to share one common rate, and that's because it should be, we should only have one true rate on one day. Otherwise, we have manipulation or arbitrage opportunities.
Okay, I can see where you're coming from, but I mean that's just the reality of the case. Because I mean, LIBOR, JIBAR is a forward-looking 3-month rate, as we pointed out, and the other ones are backward.
Yes.
So there's no good reason why it should.
And I think maybe that's why we should lean towards the alternative reference, because it's actually referring to previous transactions. But I think if LIBOR was perfectly estimated, it should be the same. Am I wrong?
And then I suppose a follow-on question is I didn't appreciate that these alternative rates are, there's no standard, like sound.
Yeah, no, there isn't. Yeah. So that's something that makes them quite.
Whereas
yeah.
the eyeballs and JIBARs, those are the standards.
Yeah.
So that's why like, every jurisdiction they have to come up with a methodology. So like in South Africa, there's a market practitioner working group, which I'm also involved into the derivative working group to make sure that we reformulate a new structure for that particular, how you handle derivatives that are based on this new alternative risk rate. Right. Yeah.
Okay.
Any question?
The question for understanding, when you give your model in the beginning, the noise term that you have, some motion.
Yes.
Where does that noise come from? What's the origin?
It's an assumption underlying the Kalman filter. We assume Gaussian noise.
I understand it's an assumption for
yeah.
In terms of the application.
Yeah. So in the financial market, there's this well study that's called market microstructure noise, and this is coming from that side. And these guys, can you go back to the reference?
This one?
Yes. Yes, they were my own. Two of them were my colleagues at the University of Technology in Sydney, and the third is a professor in market microstructure noise, and that's why they employ that models to be able to model the noise that can possibly comes from the new rates. Yeah, and
so it's an accepted model.
Yeah, yeah.
Following up on Brugler, I also thought about this. What causes the noise? As in, one of the ways the model spits out is noise, but yeah, is there stuff in the model happening that specifically causes the noise? You know?
So it will be like manipulation to the reference rate. So people just making, I guess,
yeah,
trades.
Manipulation is one of the reason that noise can come from, or maybe it's a high frequency trading in the financial market can also cause the noise.
So market conditions can bring compounded noise and so on, depending on how traded is certain day.
Yeah.
Low trading might be more noise.
Yeah, that's why a deeper market will be will be less noisy, because those big trades will be averaged out, I guess. Yeah.
Yeah, just a few remarks I have to Katherine. Katherine studied, first of all, started in January, understands the paper, which is a high-level paper, which is, of course, like I told you, it's in the Journal of Financial Economics. Financial Economics is one of the top journals in the field of finance, and was able to understand some of these models, like financial econometric models, to be able to implement. She even migrated from using R into learning Python, and was able to implement this, was able to replicate this, and I'm really proud for at the level, I mean, at the stage where she's going at the moment. Thank you, Katherine.
Thanks.
Well, it's
I'm actually really
it's going to affect us a lot because when the price goes down,
What's the background?
Thank you guys online. Thank you for attending. Really appreciate.